Adam, where's my packet?
I stole it and threw it in the trash.
No, I don't know where it is.
Let's look at number 16 on Unit 8, Worksheet 4. The odd answers are posted, so we'll work some even ones. Find the angle. Find the angle between 0 and 2 pi in radians. I guess that's a little bit repetitive because 0 to 2 pi implies radians. That is coterminal. Same ending with 23 pi over 3. 23 pi over 3. So that's way bigger than 2 pi. So somebody's done a lot of spinning around here, and I want to undo that. So what should I do to start to get a coterminal angle back down between 0 and 2 pi? Well, yes, I heard two good answers. Subtract, and then I heard common denominator. We'll subtract. What do we want to subtract? We're jumping ahead. I'll say we'll subtract 2 pi, but yes, that means we'll need a common denominator, and we'll change that to 6 pi over 3. And again, we want something between 0 and 2 pi. So 23 minus 6 is 17. So 17 pi over 3. Is that my answer? Why not? Right, it's not between 0 and 2 pi. So what do I need to do? Subtract again. This time I've already got a common denominator, so I'll just jump straight to minus 6 pi over 3. 11 pi over 3. Is that one okay? No, because it's not between 0 and 2 pi. So I'm going to subtract again. And I'm just going to keep subtracting until I get something between 0 and 2. About 5 pi over 3. Does that work? Is 5 over 3 in between 0 and 2? I'm hearing no's and yeses. Yes, right? 5/3 is almost 6/3. So that's our answer. These other ones are coterminal, but they're not the ones we want. Because we wanted one between 0 and 2 pi. Let's look at number 12. Find an angle between 0 and 360 that is coterminal with 443. Let's see, 443 is not between 0 and 360. So real similar to the one we just did, except now we're in degrees rather than radians. So instead of subtracting 2 pi, I'm going to subtract 360. And you've got a calculator, so use it if you need it. But 443 minus 360 is, I'm pretty sure, 83 degrees. Is that in between 0 and 360? Yes. It's always easier in degrees because they're not weird fractions and radians and pies. But it's the same thought process. You know, do I have an angle that's less than one full rotation? And when I do, then I'm done. Let's look at number 18. Back to radians. Find an angle between 0 and 2 pi, coterminal with negative 25 pi over 6. So that's negative. I don't want to be negative. I want to be between 0 and 2 pi. So what should I do? Add. What should I add? 2 pi. Although, be careful. When adding 2 pi, you're not going to say that that answer is negative 23, right? You're going to get a common denominator, I hope. So negative 25 plus 12 pi over 6 would be negative 13 pi over 6. Is that between 0 and 2 pi? No, it's negative, so let's keep adding until we get there. So plus 2 pi again gets us negative pi over 6. Almost there. Let's add 2 pi again. And that gets us to 11 pi over 6. Is that between 0 and 2? Yeah, barely, but yeah, because 12 over 6 would be 2. So that's our answer. These other ones were coterminal, but they weren't between 0 and 2 pi. So they were sort of right, but not the answer we were looking for. All right, let's switch to the review, and let's look at 17 and 18. Again, the answers to the odds are posted on Schoology, so you can find them. Find the reference angle. Okay, so that's nearest x-axis is what we're looking for there. 2 pi over 3. Let's see, there's 0 and 2 pi. Halfway around is pi. Half of that's pi over 2. And that bottom one is 3 pi over 2. Again, you don't have to label those every time, but if it helps to help you place 2 pi over 3, it doesn't take long and it might be worth it. So let's see, 2/3. 2/3 compared to 1/2. Is 2/3 bigger or smaller than 1/2? Bigger. 2/3 compared to 1. Yeah, they're shaking their heads. No, not bigger. So that means we land in the second quadrant. By the end of this week, we'll have a better idea of exactly where we land, but for now, all we really need to know is that we land in the second quadrant. There's 2 pi over 3. Reference angle is to the nearest x-axis. So that would be sort of the picture of the reference angle. So I need to figure out how much farther do I need to go to get to pi. So you can set up a subtraction problem, or most of you can probably just look at it and kind of think through, well, if I'm at 2/3, how much more do I need to go to get to 1? 1/3. So if you want to show the work, it's pi minus 2 pi over 3, but if you got some fraction sense, it's almost easier to just look at it and think, well, I'm 2/3 of the way there, I need to get another third. So the reference angle is pi over 3. Reference angles are always positive, so you don't have to worry about, well, did I back up or go forward? That doesn't matter. Just how far to the x-axis. Let's do number 18 as well. It's in degrees, so that makes it a little different. It's also negative, so I have to be real careful doing this. I know I'm going backwards, which means I may want to label the axes sort of backwards. So that would be backwards 90, backwards 180, backwards 270, backwards 360. Flip your brain around to work this problem. So 225. Again, it's usually easier in degrees. Bigger than 90, bigger than 180, not as big as 270. So we land in the second quadrant here. Reference angle is the nearest x-axis. So there's our reference angle. So I'm looking at that problem. I'm not really thinking about negatives. I'm thinking we rotated 225, which was past 180. How much past 180 did we go? Because that'll be our reference angle. 45. So 225 minus 180 is 45. Again, the best way is to reason through it rather than, I mean, you can write 4 different rules depending on what quadrant you're in, but I don't want to write that and then you'd be like trying to memorize 4 rules. Like, just understand what the reference angle is and then figure it out. It's always either, it's something to do with 180 or 360. How close to 180 or 360 are you? Because you want to get to the nearest x-axis. All right, let's look at 20s, because 20 has this extra thing that it's more than 360. So I think rather than graph 600, which should be like spinning around, let's use the coterminal thing and graph a coterminal angle and then find the reference angle. So it's minus 360. So that would give us 240. So 600 and 240 have the same landing spot, coterminal, same landing. Again, if you've done some of these, or enough of these, then you know where 240 is, then maybe you don't need to label them. But I'm still thinking we're kind of new at this, so 0 and 360, halfway around is 180, half of that's 90, halfway in between is 270. Again, most of you are probably to the point where you don't need to label it for degrees. You're probably still labeling it for radians. That's completely okay. 240 is between 180 and 270. Again, easier in degrees because I'm not worried about fractions. So there's 240. Again, it's not the same angle as 600, but it's the same landing spot as 600. There's my reference angle. So I'm looking at that and I'm thinking, oh, we went past 180. How far past 180 did we go? Would be our reference angle. At least for this one anyway. We went 60 degrees past it. When I first drew this, I almost said we're only 30 degrees from the y-axis, and that's a true statement, but we don't really care about that. So again, it's not get to the closest axis, it's get to the x-axis for a reference angle. Let's look at number 3 on the review. 8 review. Secant. Okay, I don't know secant. I just know that it's the flip of cosine. Cosine is a over h, so that means secant is h over a. Again, if you have h over a memorized as part of secant, that's fine. I don't memorize them that way. I know who the partners are. So I need a and h to figure out secant. So there's a, there's opposite, and there's h. Well, of course they did. They made us do a little bit more work before we can figure out the ratio, because we don't know what a is. So 14 squared plus b squared equals 14 square root of 2 squared. If you recognize that as a special right triangle, you might already know what this side is.
Okay.
If not, then it's fine. You're just going to work the problem kind of like normal. 14 square root of 2 squared minus 14 squared is 196. So b squared is 196. And if we take the square root of that, we get 14. And then maybe we realize, oh, wait a minute, that's got to be a 45, 45, 90 right triangle. Whatever, if we didn't see that, it's fine now, it doesn't matter. So h over a would be 14 square root of 2 over 14. Now the 14s will reduce, and I'm left with square root of 2 for the secant of that angle. For most of those angles in 1 through 4, we don't even know what the angle is. This one, because it happens to be 45, we know the angle, but that's fine. That's not what it's asking us for. It's asking us for the secant of that angle.